Good morning, all of you. And this is Dr. Kavita Kotireddy. In today's session, we are going to discuss about the most important topic that is called how can we say hydrogen is considered as a fuel of future, right? So here in general, we have so many kind of energy resources available in our surroundings. As we already know, there is a great demand for the energy. So we are depending upon so many kind of resources in order to get these type of fuels and even electricity that is becoming the economical burden. In order to avoid all these and even switch it to renewable and a more safe kind of energy source, here the more important source is considered as a hydrogen. Hydrogen fuel is considered as a fuel of future. So in today's session, we are purely focusing on how can we say hydrogen is a fuel of future and what kind of demand is there and in what way it can be synthesized, what kind of applications we can notice with regarding that hydrogen as a fuel. Let us move on to our today's session. Right. So here, see, you can find hydrogen is becoming the fuel, and even it is used as a vehicular fuel in addition to the traditional fossil fuels, whichever available, like petroleum, diesel, and so many type of other fuels also in our use. So in addition to all these, we can switch into this hydrogen as a future fuel. So there is a lot many research findings and lot many efforts are going to be transformed in order to make this hydrogen as a fuel, convenient fuel, and which is abundant in nature. In order to make all this possible, hydrogen synthesis is required. So first of all, we have to see what kind of properties which are taking for this hydrogen for considering as a fuel of the future. So detailed discussion is going to be provided here. First of all, what kind of properties are provided by this hydrogen and what are the major sources of this hydrogen as a fuel. In order to synthesize this hydrogen, and what kind of advantages we can find over any other kind of fuels, in general we are using, and what are the important applications and what kind of research is in progress. So in India, what is the mission of hydrogen? National Hydrogen Mission was launched, and what are the objectives of all those, and what way the synthetic progress is going on. Everything is going to be covered in today's session. Let us move on to this hydrogen. So as already we know, hydrogen is the element and the periodic table is the first element. So among all the known elements, and it will be the lightest known element, being it is atomic number is one, atomic weight is also one as well, right? So here no neutrons present in this. That's the reason why one and only one element in the entire periodic table residing, atomic number and atomic mass, both are one itself. Right. So here hydrogen can be stored in these cylinders and even transported conveniently. And so here it is considered as the lightest known element. As we already noticed, hydrogen symbolized with a capital H. Atomic number is regarded as one, and atomic mass almost equal, because only this is regarding the weight of the proton, which is present in the central nucleus over here. 1.00794 is the atomic mass of this hydrogen. And the element was discovered in the year 1766 by the Henry Cavendish, the scientist who gave us this most precious element called hydrogen, and it resides in the S block in the entire periodic table. S block, it is the starting element. Entire table will be started with this one, and always it found in diatomic state, like hydrogen. Single bond hydrogen will be there, and we found the three kind of isotopes for this hydrogen. One is protium, second is deuterium, third is about tritium. Right? Protium is nothing but one proton, zero neutrons. Deuterium with what? One proton, one neutron will be there, hence atomic mass will be 2. Tritium with a one proton, 2 neutrons will be there, hence atomic number will be 3. So these many kind of isotopes are available, and allotropic forms are not found for this one, and the density is extremely less. 0.000082 will be the density of this hydrogen, being it is a lighter element in the nature. And its electronic configuration being it is atomic number 1, only one electron resides in its outer shell orbital, s orbital. So it is considered as s block 1s1 is electronic configuration of this. Let us compare all these isotopic forms available for hydrogen. Hydrogen 1 is considered as a protium whose number of protons or atomic number is regarded as 1. Neutrons are 0 in this, hence its atomic mass exactly equals to proton mass, and that is the 1.007. So it is represented as H1 superscript 1 subscript because atomic number, atomic mass both are 1. And natural abundance among all three kind of isotopes, its abundance will be highest, that is 99.98%. Most of the hydrogen is available in this form itself. And second is about deuterium. Deuterium is symbolized with capital D, whose number of protons will be again 1, but number of neutrons are 1, hence it is regarded as atomic mass will be 2. And here atomic mass is 2 superscript, atomic number is 1. Its abundance will be extremely low. 0.0026 is the percentage abundance of this deuterium, which is regarded as a hydrogen 2. Tritium is nothing but where atomic mass residing for this isotope will be 3, hence it is a tritium. Hydrogen 3 in general we can say number of protons are exactly same, that is 1 itself, but neutrons are 2. Atomic mass will be 3 and 3 atomic mass and 1 atomic number. This will be the symbolization for this tritium. Extremely lesser percentage, it is almost a trace element we can't find in general. So why we have to choose this hydrogen as the fuel of the future? In order to get that, first of all, we have to go with what are the important characteristics. So some important criteria, parameters we have to understand about this hydrogen. Hydrogen being it is non-toxic, even by inhalation, it will not cause any kind of hazardous effect, and highly combustible. So what extent we are supplying, that extent it will burn. Hence we can say highly combustible. Upon combustion, safe fuel, safe energy will be released by this combustion process. Hence it is highly what advantageous for us. And second is about hydrogen under standard conditions, it will be a diatomic molecule, can be regarded as H single bond H. H2 is a molecular formula of hydrogen, H2, right? It will be a colorless, odorless, and tasteless. You can find these many applications for hydrogen. You can use this hydrogen for fueling of vehicles and alternate for the fossil fuel, and even in the ammonia synthesis and the fertilizer manufacturing, this hydrogen can be utilized. And even in the refining of petroleum fuels, hydrogen plays a vital role, and so many kind of compounds in the nature and even in the synthetic origin made up of this hydrogen. Simply we can say hydrocarbons are bonded with the carbon and hydrogen itself. Water, which is abundant material on the earth, composed of hydrogen and oxygen as well. In this regard, hydrogen plays a vital role in the combination, being it is a lighter weight, highly reactive, and found in so many kind of compounds of natural origin, and even in the synthetic laboratory materials. Let us go with their common properties. Molecular weight is regarded for hydrogen will be, being it is atomic, we are not considering atomic weight, molecular weight being 2 hydrogens get combined, so atomic weight will be 2. Density in a gram per meter cube will be taken as a 0.083. Higher calorific value among all the known elements in the entire periodic table, highest calorific value in the sense heat amount energy, energy released during the combustion of unit volume of the fuel is regarded as the calorific value. Any fuel efficiency can be measured, can be quantified in terms of this calorific value only. Higher the calorific value, greater will be the efficiency of the fuel. Among all the known elements, here higher calorific value is assigned for this hydrogen only. That's the main specific reason to choose hydrogen as a fuel of future. Right, high calorific value is given as 141.9, and the low calorific value, if we are excluding all the exhausted gases, combusted gases, then it will be 119.9 low calorific value. So it will be extremely larger in the quantity when compared to all the remaining elements. as we aware that in the entire universe, where upon combustion, the heat providing, energy providing elements are only carbon, sulfur, hydrogen. Among these three elements, extremely high amount of energy during the combustion will be liberated from this hydrogen itself. Next boiling point, it will boil at 294 degrees centigrade temperature, and the density is regarded as a 70.8 kilogram per meter cube. Density as a liquid when it is compressed under high pressure. So under this condition, 70.8 kilogram per meter cube will be the density, and the critical point critical temperature 306, pressure will be 12.8, and the density will be 31.4. These are the critical conditions. And the what flame catching tendency or inflammable tendency will be provided at 585 extremely high temperature conditions, and air ignition limit will be 2045 volume percentage will be there. Diffusion coefficient will be 0.61. Specific heat of this is the specific parameter 14.8 kilojoules per kilogram Kelvin. So these are the general physical properties of hydrogen. Now let us see what is the abundance of hydrogen in the universe. When you consider the entire universe made up of all kind of stars and solar system and planets, so many, all these things are collectively considered as a universe. And this universe major part is composed by this hydrogen only. This is the most abundantly valuable element in the universe. Around 91% of the universe is composed by hydrogen gas itself. And earth crust, it will be 60%. Oxygen will be 60%. Hydrogen quantity will be 2.9% in general. But in the universe, if you consider, especially when you go with the solar system, the center of the sun, you can find hydrogen. These hydrogen get combined to combined by the nuclear fusion reaction in order to generate the helium molecule. Helium is a noble gas element which is formed by the combination of lighter weight hydrogen atoms by the process called nuclear fusion, so that here uncontrolled or continuous amount of energy generated in the solar system. That is the main origin for the sunlight. So we are availing sunlight in general, and that is available continuously. So this hydrogen is the main cause for the generation of that sunlight. So this is about the abundance. In the universe, the major quantity is resided with the hydrogen itself, and the very minute quantity will be for all the remaining elements. But in case of earth crust, when you consider earth as a planet, in this here oxygen is the major element which can be found, but hydrogen quantity will be extremely low. But fortunately, earth is covered by water itself, 75% of terrestrial region completely covered, completely submerged in the water region. That's the reason why hydrogen is abundant even in the earth's surface. We can find, so we can separate that hydrogen from the water, and it is possible to synthesize hydrogen. The bulk quantity industrial scale synthesis is possible. Then what is hydrogen? Why we have to focus on this? Let us see. So hydrogen is the lightest, as we are aware. This is the element number 1 in the entire periodic table, and it is the lightest element. So it is very convenient to carry. It is convenient to work with this, and most abundant in the universe. Just now we saw it is the most abundant in the entire universe. On the earth, hydrogen is found in the more complex compounds. Whatever compound you take, in most of the compounds you can find the hydrogen, not in all. I'm not saying like that, but in most of the compounds you can find hydrogen. Combined compounds never find alone. Being it is highly reactive molecule, always it can be associated with some other elements in the form of hydrates, in the form of hydroxides, in the form of hydrocarbons. In so many ways, hydrogen is available in the on the earth. It will be in a combined form. Hydrocarbons are available here. Then fuel of stars. As we already know that in the entire universe, so many stars, so many galaxies, so many systems are present. Most of the stars are covered with this hydrogen as a major component. Being entire universe is covered 91% by this hydrogen, so that it is abundant element which is the fuel of stars. Stars are continuously sprinkling. We are not able to see that shining stars in the daytime because of radiation. So but they are continuously shining. So that shining of stars are purely because of this hydrogen. Hydrogen is a fuel for that shining tendency because of that radiation, that light generation, energy generation in the stars. So here the chemical phenomenon associated with this will be nuclear fusion reaction. Smaller, lighter hydrogen atoms get combined so that here noble gas helium will be generated. So during the generation of noble gas helium, unquantifiable energy will be released along with that. That is the main cause for this radiation or energy associated with the stars, even sun. So here you can find a few of the applications of hydrogen. Here you can see hydrogen balloons are there, which are working, being it is a lighter element, parachutes are made with this. So here transportation is possible, and essential element, hydrogen is the essential element for the manufacturing of fertilizers, which are the nutrients provided for the croplands. And this is another petroleum fuel refining. So in this process also burning of fuel requires hydrogen. So here also we are using this hydrogen. Now let us see what is meant by green hydrogen. Hydrogen which synthesized under greener process purely from the greener conditions is considered to be a green hydrogen. Green hydrogen could be a critical enabler of global transition to sustainable energy. So entire globe, entire universe, entire people across the continents are looking forward for the sustainability. Especially in the 21st century, most of the people are conscious and considering the sustainability and the global welfare as the prime intention. That's the reason why they are shifting, they are switching towards this greener conditions. So in that regard, here there is a critical requirement for the green hydrogen because of its eminent properties, eminent applications. That's the reason why. So all across the globe here, zero emission economies are the major concern. That's the reason why carbon dioxide levels should be minimized in order to enable, in order to make practice of this kind of conditions. Green hydrogen plays a vital role over here. There is an unprecedented momentum in the world to fulfill hydrogen long-standing potential because in order to enable this hydrogen as a fuel. So here, then only it is possible to achieve this zero emission economies and a clean energy solution and the sustainability. All these goals will be fulfilled. This is only the possibility to achieve all these holistic goals. Green hydrogen catapult, a United Nations initiative to bring down the cost of green hydrogen, announced that almost doubling the goal for the green electrolyzer from 25 gigawatts at last year, 45 gigawatts by 2027. Hydrogen production should be raised and the production charges should be cut down in order to make the practice of producing this hydrogen in all across the globe. That's the reason why United Nations took the initiative for the production of this green hydrogen, and 45 gigawatts power can be generated with the help of this hydrogen by the year 2027. The European Commission has also adopted the set of legislative protocols in order to facilitate the production, especially in concern with the renewable and hydrogen production, to give the energy security to all the European citizens. So this is also the goal which they framed. So green hydrogen plays a vital role to recover the economies, to wide the hurdle of imports and zero emission. This is a major concern in order to make the sustainability over the environmental conditions. So in order to achieve all these, green hydrogen enabling is the major role. Now let us see where can we find this hydrogen, where hydrogen is available on the earth. As already we are aware that water is abundant quantity on the earth, 75% under water. Only 25% open terrestrial region is available. Water is composed of H2O, and so many forms of water, oceans, so many flowing rivers are available, glaciers, deposits of water in the form of solid at low temperature are available, and even small streams, canals, underground aquifers. In all these regions, you can find water where hydrogen and oxygen are the elements which are present in this water molecule. Apart from this, methane, this is also another major gas available on the earth crust. So here methane, this is the major component of natural gas, where carbon surrounded with 4 hydrogen in its tetrahedral vicinity. So here it is also the major source for the hydrogen. And neither you can find hydrogen on the earth. So here astronomers believe that 90% of the universe is completely covered with this hydrogen. Just now we discussed regarding this. Hydrogen is a component of most of the elements, and when you go with the elements like petroleum. So as already we know that petroleum is a combination of hydrocarbons only. Carbon and hydrogens are available in this based on its fraction, based on its molecular weight. Different kind of components will be there. If hydrocarbon range will be C1 to C2, that will be natural gas. If we move in the ascending direction, what happens? Carbon hydrogen number will be raised, and gaseous to liquid, liquid to solid state are possible. Viscosity gradually increases. In that manner, you can find a natural gas, and followed by petroleum ether, and a petroleum called gasoline is available. Diesel, naphtha, kerosene, lubricants, wax, all these are the components which are present in this crude petroleum oil. All are composed by this carbon and hydrogen, being it is a hydrocarbon. And the minerals, so here hydrogen containing minerals are available either in the form of bicarbonates or else hydroxides or else hydrides, also available in the nature. So minerals also composed by these hydrogen. And in either is about cellulose. Cellulose is nothing but it is a polymeric compound formed by the repeated combination of the glucose molecule. So where C6, H12, O6 will be there. That's the reason why hydrogen is a major component in the cellulose as well as a major component present in the plant kingdom. In either is about starch. Starch is also made up of that polymeric compound of glucose, but the binding tendency will be somewhat altered. So that here also you can find hydrogen. And the sugars. These sugars are made up of sugars are nothing but carbohydrates. Carbohydrates also having hydrogen is a major element. Fats are nothing but long chain carboxylic acids composed of unsaturated carbon-carbon double bonds, either triple bonds also present. Such a kind of compounds are present in these oils and fats. So all these oils and fats are also made up of carbon, hydrogen, and in either functional group like oxygen as well. So in this way, you may go with alcohol, acids, and other substances as well. In all these compounds, you can find hydrogen as the major element, so that here most of the compounds in the universe are composed by this hydrogen. And move on to sun. So this is the major source. Whatever energy available in the earth, all are primarily extracted from the sunlight itself. Sunlight is a continuous radiation available in the form of sun radiation. So among the entire sunlight available falling on the earth, we are consuming 1%, and the remaining will be reported back into the universe, right? So here that continuous radiation generated in the sun, that is purely because of hydrogen. Being sun is composed of 73% of hydrogen, 20% helium, and 2% other elements also present. In this core sector of the sun, the major component is hydrogen, which participate in the nuclear fusion. Just now we discussed. It's a kind of a combination of the lighter elements, and so that here noble gas helium got generated along with the unconditional amount of energy, right? So here that's the reason why sun is always looks like a burning particle, and associated with this extent of heat and light. Sunlight is associated with the two kind of energy sources. One is heat, second is light, right? So here around 6,000 degrees centigrade temperature is associated with the sun. So that is purely because of this hydrogen combination to provide this helium as a final compound. So that's the reason why the main source of energy generated by sunlight will be a hydrogen itself. Hydrogen shell will be present here. This is a kind of representation how the elements are present in this solar system, our sun. So here hydrogen shell is present in this region. You can find the green circle over here, that is composed of hydrogen, and here yellow color as a helium core will be there. This is composed of helium, and another green circle which is a denser here, that is helium fusion region will be there, and the central part is composed by carbon and oxygen core will be there. And this is about the entire composition of sun, where hydrogen will be there in the external circle so that it will participate in the nuclear fusion reaction. Now let us see how the fusion is possible. Hydrogen, it is the chain process, continuous process. That's the reason why continuous amount of energy will be liberated during this nuclear fusion reaction. So this is the important phenomenon which is provided by the stellar nucleosynthesis process, where hydrogen atoms of unimolecular get combined in this manner. So when hydrogen atoms combine, so that here the formation of helium nucleus along with a lot of energy that may be either in the form of heat as well as in the form of light, right? So here heat and light amount will be generated, that the process will be continued, so that here continuous generation of energy is possible at the core of sun. It will be transmitted to the earth through the atmosphere. So here stars are continuously shining because of this hydrogen nuclear fusion reactions itself. Okay, so here still stellar nucleosynthesis that powers stars and sun purely shining because of these are self-luminous in nature. So they are self-luminous, they are producing their own energy for shining purpose, right? So that's the reason why here that self-luminous nature of sun and other stars purely because of nuclear fusion of these hydrogen atoms to convert into a helium nucleus. So that's the reason why the fusion, the nucleus starts starting with the initial hydrogen and helium abundance provides that energy synthesize a new nuclei. Different reaction chains are involved depending upon the mass of the star. So this will be a continuous process, continuous collision is possible, continuous new molecules will be generated along with a lot of energy liberation. And that energy will initiate another molecule to participate in the nuclear fusion reaction. In 1920, Arthur Eddington anticipated discovery and mechanism of nuclear fusion process in the stars, and his paper are internal constitution of the stars. He mechanized, he understood, and he formulated the certain process, how the sequential scientific process is possible in the sun in order to get this extent of energy that is purely provided in his scientific manuscript called internal constitution of the stars. And this is the chemistry which involved in this nuclear fusion reaction. You can observe hydrogen being it is a gaseous lighter weight molecule, 2 moles are required in order to combine. And with the oxygen, another oxygen is also gaseous substance, so that they get combined to give the water molecule. This is a kind of combustion process. So while burning, so when we are burning hydrogen, combustion is nothing but burning in the presence of excess of oxygen is denoted as a combustion. Always combustion gives rise to combustion products along with a lot of energy. So combustion gives rise to energy. When we are taking coal, for example, upon firing that one, upon giving external heat to that one, what happens? It will continuously burn. While burning of coal, what happens? A lot of energy is also liberated. That is the simplest process for the combustion. In the similar fashion, hydrogen will participate in the combustion in the presence of oxygen. It's a lightening element, that means a burning element essential for burning process, so that here after burning you will get the combustion product, that is water itself, being it is highly environmental friendly, no emissions are harmful during this combustion process. That's the reason why entire research purely focusing on this hydrogen is taking as a fuel. So if you're combusting hydrogen will not cause any kind of harm to the environment. That's the reason why it will be 100% environmentally benign. Zero emission will be there with this. Any harmful emissions during this process of combustion, not at all possible with this. That's the reason why it will be a interest of research, interest of this adopting as a fuel. Now let us see how the combustion process is possible. We are taking 2 moles of hydrogen, and in the presence of excess of oxygen, we are burning. So heat will be liberated during the process. This is called a combustion. While combusting these two elements, like these two molecules like hydrogen and oxygen, there is a formation of water as a combustible product, along with the liberation of excess amount of energy. Both are useful. So whatever products generated may not be wasted. Water is essential as well as energy, which we can store and can be carve into any kind of uses. We can such as electricity, we can utilize this one, and in order to run the vehicles in automobile industry, it will work like a fuel. In industrial purpose, in order to generate the steam and also to run the machines, it is very essential in this way. So here it can be taken as a fuel in industrial purpose, also in the space applications, astronomy purpose, and also even in the household purpose, we can apply this hydrogen as a fuel. So this is a kind of process possible by the combustion of hydrogen. These are the products which are not at all environmentally harmful, hazardous, toxic. Now let us compare. So we are doing all these things, fine. And this is the energy generated. This is a kind of process, and these are the products generated. Now we have to take the comparison of the combustion of this hydrogen with other elements as well. Then only we can understand the efficiency of this one. So already we are aware that only these 3 elements are used to give. What are those? Carbon, hydrogen, sulfur. These 3 elements are responsible in order to give the heat while burning process. Even some other elements also present, but amount of energy liberated will be negligible. So that need not to consider those elements for this calorific value. Calorific value is provided by carbon, hydrogen, sulfur elements only. Now, among these 3 elements, calorific value is nothing but amount of heat evolved during the burning of unit volume. For example, we are taking 1 kg of the fuel. During 1 kg of fuel burning, how much heat evolved, how much energy evolved? We are comparing for these 3 elements. Now let us see. Burning of carbon will generate 8,080 calorific value heat or energy evolved. Hydrogen while combustion, 34,500 calorific value of energy evolved, while sulfur upon combustion, 2,240 calorific value of energy is provided. So that if we compare these 3 elements, only these are the elements responsible to provide the calorific value upon combustion process. So even among these 3, hydrogen is more superior when compared to these 2, right? So after hydrogen, carbon, being it is abundantly available in the universe in the form of coal, in the form of petrol, diesel, kerosene, naphtha as well. That's the reason why carbon also found wide applications in a fuel industry. That's the reason why. So here, superior element will be hydrogen only. That's why here it will become the fuel of the future. In the elemental comparison, it's very confirmed that hydrogen fuel having highest amount of calorific value. Now, let us compare the fuel efficiency of this hydrogen in terms of fuel. So here elemental comparison got completed. Now let us take different fuels. Let us combust them. Kg of fuel was taken. How much energy liberated in the form of kilojoules we are going to measure over here. Right. So here cow dung was taken, dry cow dung was taken, and 1 kg of cow dung and subjected to burning, combustion. Upon combustion, 6,000 to 8,000 kilojoules of heat evolved. And wood upon combustion, dry wood we are taking, that is not wet one. 17 to 22,000 kilojoules per kilogram of wood energy will be released. This is the calorific value of wood. Coal 25,000 to 33, petrol upon combustion 45,000, kerosene 45,000, diesel 45,000, methane 50,000 kilojoules per kg, compressed natural gas 50,000 kilojoules per kg, Liquid petroleum gas 55,000 kilojoules per kg. It is the most widely applied the household fuel. Biogas, it is generated from the animal excretes, especially in the rural region. We are employing this biogas where 35,000 to 40,000 kilojoules per kg of calorific value is employed. Whenever you consider hydrogen, 150,000 kilojoules per kg is the calorific value for this one. That's the reason why it will be the efficient fuel. We are taking same quantity may not be varied, kilogram of these fuels are considered, but efficiency of energy production will be extremely large for the fuel called hydrogen. In terms of elements, in terms of fuel, you can observe that hydrogen is a more efficient fuel among all the known combustion elements. So that's the reason why it is regarded as a hydrogen is a fuel of future. Yes, exactly. Right. So now move on to the context of ARENA. ARENA is nothing but International Renewable Energy Agency. International Renewable Energy Agency suggests that share of hydrogen in the 2050 energy mix should be 12%. Wherever we are using energy, there should be 12% through the hydrogen itself. Because zero emissions are possible with this hydrogen. That's the reason why they are fixing the goals, fixing the targets. We have to blend 12% of hydrogen wherever energy means of utilizations are available. It says 66% of hydrogen to be used by 2050 needs to be green, produced from the water as compared to the natural gas. Even different sources of hydrogen gas synthesis are available, being water is abundantly available and so many oceans are rich in the water quantity. That is the reason why converting that water into a hydrogen that is a green fuel. So this will be the major intention of the ARENA in order to switch into the green sustainable protocols. So this will be the target by ARENA, and a sequential proposal is also provided here that hydrogen produced can be used either for aviation purpose, heavy duty vehicles, logistics, cargo, shipping. For all these we can apply. Fuel cells, electric vehicles, especially here in entire mechanism of combustion in the automobile system will be switched into the fuel cell system in electric vehicles. Now the future purely lays in electrical vehicles, especially this hydrogen fueled fuel cells and SC trains. So here train transportation also looking towards this hydrogen, and even in shipping, marine transportation being it is a larger extent transportation available in order to connect all the regions over the world. So here also we are looking forward for this hydrogen to fuel these vehicles in order to move, in order to supply, in order to transport. Now let us see how can we consider this hydrogen as a fuel of future. Some of the important advantages are there. We can observe over here. Excellent energy carrier it will be. Energy carrier tendency will be extremely large. That will be 142 mg per kilogram will be there. Clean fuel with zero green emissions upon combustion will not emit any kind of harmful gases. Hazardous emissions will not be there. And diverse domestic sources. So many kind of compounds are there in order to synthesize this hydrogen. That's why sources of raw materials are extremely large, economically competitive. With the lesser extent of expenditure, we can provide the larger extent of hydrogen. That's the reason why it is more precious, economic in nature. Better security than other commercial fuels. It will provide the greater security. Energy security provided with the hydrogen will be extremely large because water available everywhere. That's the reason why we can focus to improve the efficiency of hydrogen production, so that it will give the higher security in terms of energy. If energy security is there, automatically remaining all kind of hurdles will be solved. So faster refueling time, being it is a lighter in weight, it is possible to refuel in the very shortest span of time. So these many advantages we can notice with this hydrogen fuel. Not only this, hydrogen also used in the semiconductor manufacturing. This is another added advantage along with the fuel. In the manufacturing of materials, advanced materials, especially electronic gadgets, now semiconductors, and these chips are very essential where hydrogen plays a vital role in order to synthesize them. Now let us see how advantageous it will be, how hydrogen will be advantageous, why we have to consider hydrogen as the fuel of future, because greenest source of power, being it is combusted to giving water as the final product alone, along with a lot of energy without emitting any harmful gases like carbon dioxide, dihydrogen sulfide, any other hazardous products will not be generated. That's the reason why greenest source we can consider. And zero greenhouse gas emissions. Especially greenhouse gases are the major component will be carbon dioxide. Along with that, methane will be there, water vapor will be there. So here greenhouse emissions will be zero for this one. So that here zero greenhouse gas will be achieved by this switching to hydrogen as a fuel. Renewable source of energy. Hydrogen is considered as a renewable source of energy because abundantly available. So many raw materials are there, not a single compound. Water abundantly available, natural gas abundantly available. From the waste also we can collect hydrogen. So that so many kind of sources are there, so that we can consider it as a renewable, not extincted from the universe, abundantly available. And high efficiency will be there. Energy efficiency compared to remaining all the elements, remaining all the fuels, its efficiency will be extremely large. So here, efficient source of the power. And easiest means of transport, being it is a lighter weight element, can be compressed so that here maximum extent can be transported in the short while. So here transportation will be very easy in nature. And the fuel of high economy, because manufacturing raw materials are abundantly available. Raw material shortage may not be possible, need not to import from other country, and need not to put much efforts, much economy, much expenditure on this synthesis. That's the reason why economically it is profitable in nature, more beneficial in nature. So no matter of any pollution, air pollution is not possible because water may not cause any air pollution. During the synthesis, manufacturing, and upon combustion, it may not cause any noise pollution, as well as any water pollution is not possible. Terrestrial pollution is not possible, so that it will not cause any kind of harmful hazardous effects to the universe, to the ecosystem, to the environment, even to the mankind. So here pollution-free process are possible with this hydrogen as a fuel. Next, quick refueling time, being it is a lighter, and its expansion will be much more faster in nature. It is moving at the faster speed. That's the reason why fueling will be possible within the short span of time. So here quick refueling is also possible. Now, import burden, because most of the countries' economies are so that dividend purely for importing the fuel, major concern, because all the countries not able to get that extent of resources of petroleum resources are not possible. But there is a gradual increase in the automobile usage. So here transportation is becoming the major demand for this fuel. That's the reason why country will majorly depending upon other countries, and the major imports are possible, especially in the case of this kind of fuels only. That's the reason why major quantity of economy are departing for this fuel import. So when we are switching to this hydrogen, the country will become self-sufficient, so that here import burden will be prohibited and economic security will be possible. Energy security, consequently, economic security is possible. Now, these many advantages we can observe. So if we observe all these advantages, now let us go with how can we synthesize this hydrogen? How it is possible to synthesize? Now let us look into this kind of hydrogen synthesis. Electrolysis. So as already we are aware, water is the major source for this hydrogen manufacturing. So here water composed by triatomic bent molecule, 2 oxygens, 1 hydrogen will be there. If we supply electricity, we can depart all these elements, and the hydrogen, oxygen, 2 gases will be evolved during the electrolysis process. Now let us see How can we synthesize? An electrolytic current splits water molecule into hydrogen and oxygen. Electrolysis is nothing but two electrodes are immersed into electrolytic solution, which are departed, which are separated by a membrane. And here we are supplying the electricity from the external source. When current imbibed, current passed into the system, what happens? They will participate in the chemical reactions. Here one of the chamber is regarded as a cathode. In either chamber will be an anodic region, where cathode is made up of platinum, anode is made up of nickel. Nickel plate, nickel rod was taken, and both are now connected to the external circuit of electricity, right? So what we are doing, we are putting water over here, and this water, one of the compartment, which compartment? Cathodic compartment is added with the electrolytic solution, that is sulfuric acid will be added. In either compartment said to be a anode, where alkaline solution, potassium hydroxide, is added to this water. Right. What acid will do? Acid will liberate H plus ions. And here also water is having H plus and OH minus ion. These H plus will accept current from the external source. We are giving external current, right? That external current will be accepted in the form of electrons by these H plus ions, so that positively charged protons now turned into a molecular hydrogen, so that hydrogen gas is evolved at cathodic region. You can collect hydrogen gas over here. Now, move on to anode, where what we are giving OH minus, alkaline ions are provided. These alkaline ions will accept the electrons from the current source, which are giving from the external source, so that here what happens, they will lose electrons. They will lose electrons at this anodic region. Being anode is electron rich in nature, electron lost during the process, so that hydroxide now turned into water and liberating oxygen. Water mixed into electrolyte, oxygen being it is a gaseous element, will evolve outside. In this manner, chemistry involved in this electrolysis process will be, at the cathodic region, you can collect hydrogen as a gaseous element and a pure state under acidified conditions. In either compartment anode, where alkaline conditions are provided, so that water will split in this manner, so and oxygen gas evolved over anodic region. So here emissions are possible in different compartments, and external current supply is required in order to split this water molecule into hydrogen and oxygen molecule. Now let us see, wherein hydrogen is produced inside the acidic solution, oxygen evolved in the alkaline condition. Just now we discussed regarding this. Membrane is employed in between in order to restrain the neutralization, in order to avoid the intermixing of both the solution, both the compartment. That's the reason why here membrane used to depart both the compartments. And the acidic alkaline amphoteric electrolyzer will be employed over here. Rate of hydrogen production achieves over 4 times higher than the alkaline aqueous solution. In this process, the production of hydrogen and oxygen will be extremely large under these conditions, and the energy consumption is reduced approximately 30% under current density, 200 milliamperes per centimeter square. 2.2 voltage of current supply is required over here. So in this manner, we have to set up the entire system, where acidic solution will be employed in a cathodic chamber. Anodic chamber is composed with the alkaline solution. So cathode will liberate hydrogen, anode will liberate oxygen. This will be the electrolysis of water. And detailed data is provided over here. This is the data which is collected from the energy efficiency and renewable energy, where in either way for the industrial large scale synthesis of hydrogen is possible over here. And a polymer electrolyte membrane was chosen. This is a polymeric substance in order to depart, in order to stratify anode and cathodic compartment over here. That polymer electrolyte membrane is inserted in between, and water react with the anode to form the oxygen. As already we are aware, at anodic region, oxygen will be evolved, and the positively charged hydrogen ions and protons. Electrons flow through the external circuit to the hydrogen ions, selectively move across the polymeric electrolyte membrane to the cathodic region. Here in the anodic chamber, oxygen gas evolved, along with that electrons got evolved. these electrons will move on to cathodic chamber through this membrane, which is separating these two chambers, right? So at the cathodic chamber, hydrogen gas combined with electrons. Hydrogen gas will be combined with electrons, so that here hydrogen gas evolved over here. Now let us see how the reaction can be observed. Anode compartment, water, now splitting in the presence of external current into oxygen. H plus ions also liberated and electrons got released over here. The electrons liberated and H plus ions liberated in the anodic compartment move through the polymeric electrolyte membrane. So this is a membrane which used to stratify both the compartments, where here flow of electrons, flow of ions are possible. And cathodic region is accepting the electrons released in the anodic chamber. H plus ions now turned into hydrogen gas. Anodic chamber releasing oxygen, cathodic chamber releasing hydrogen gas. This is the chemistry involved in this production of hydrogen by the electrolysis of water. Right. In addition, natural gas is also another source for the production of hydrogen, where natural gas is composed by lower hydrocarbons like methane, ethane, where carbons are surrounded with the 4 hydrogens. So here what we have to do, natural gas should be fed into this one. And this is also data collected from energy efficiency and renewable energy, where natural gas will be fed into this one. Fed purification. So here natural gas get purified over here. Steam is employed over here. In the presence of steam, steam is nothing but hot water vapor is said to be a steam. That steam is also combined with this natural gas and high temperature converter. This is a chamber where high temperature is provided, and steam will be added over here, and the low temperature converter will be there. So high temperature to low temperature conversion is possible, and here splitting of natural gas is possible, and condensation of the products are possible. Here natural gas is composed by carbon and hydrogen, right? Where hydrogen evolved, as well as along with hydrogen, carbon dioxide is also evolved in the process, because the steam is releasing oxygen. Natural gas is releasing carbon, so that they get mixed and converted into carbon dioxide. This is a chamber where you can discard carbon dioxide from that, so that purified hydrogen will be evolved over here. So here methanation is possible, and finally here green hydrogen is provided. So in the entire process, first of all, we are taking natural gas, being it is naturally available. It will be the higher layer of the petroleum resources, where lower molecular weight hydrocarbons are present. This fraction will be taken and can be blended with the steam, hot water vapor, which resided with 3000 degrees centigrade temperature. And this natural gas along with steam is used to enter into a high temperature chamber, and the steam get inserted into this, and it can be turned into a low temperature. Switching of temperature is possible, so that here splitting of natural gas molecules and the steam molecules are possible. There is two kind of molecules got generated. One is what? One is carbon dioxide, and other is hydrogen. Here, decarboxylation chamber is there, carbon dioxide removing chamber, which used to discard this carbon dioxide, and the purified hydrogen will be formed in the form of green hydrogen. This is a kind of natural gas reforming, which is called a gasification process. Now, in either process also in a progress, but it is underway. So research is going on. But if all these come into reality, it will be more advantageous in order to extract, in order to synthesize the hydrogen as a fuel in the bulk quantity. Industrially high commercial scale synthesis is possible. What are the process under progress? High temperature water splitting. Water subjected to high temperature condition, at that high temperature splitting of water molecule into hydrogen and oxygen is possible. This is a kind of splitting of water molecule under thermal condition. We can say thermal water splitting. And photobiological water splitting. Photobiological in the sense, photo in the sense sunlight, biological in the sense we can use some kind of microbes. They are specifically used to split the water molecules. Under sunlight conditions, especially green algae, they used to consume the water, right? So whenever water consumed by them, they release hydrogen as a byproduct. So in that manner, hydrogen gas evolved during the biological process. So it is also in either water splitting process naturally. In either photo electrochemical in the sense, what we will do, Semiconductors will be employed over here and energy will be supplied so that here splitting of water molecules into hydrogen and oxygen are possible. Simply it is manifested here. Water molecule being it is the oxygen, hydrogen, oxygen, two water molecule we are taking into our consideration. Upon either of the condition, you may go with the temperature rise or microbial action or electrochemical action will be employed over here. So that hydrogen atoms get combined to give the hydrogen molecule, and here hydrogen molecules got generated and oxygen molecule is in either byproduct, which is also essential in order to construct the hydrogen oxygen fuel cell, right? So in this manner, here water gets splitted into hydrogen and oxygen, either of the process. So the most convenient way will be electrolysis, where continuous splitting of water molecule in the presence of external electrical current is possible. It is more advantageous in order to synthesize water, hydrogen gas from water, right? So here, if we utilize this solar radiation or solar electricity, so solar power driven electricity, in order to electrolyze this entire water molecule electrolysis process, purely it will become renewable and 100% benefits we can avail. So sunlight is transformed into electricity. So being it is 100% renewable in nature, that used to electrolyze this water molecule. Upon electrolysis, hydrogen gas evolved that can be used in various purpose. So here no way emissions of hazardous from the source to the execution process. This will be the entire advantageous method for the production as well as operation of hydrogen gas. Now, supplying hydrogen to industrial users is a major business all across the world right now, because hydrogen of high demand. For every process we can employ, we can apply this hydrogen as a fuel. That's the reason why most of the industrialists, businessmen, and whatever the processes are there, they are looking forward for using this hydrogen. So here the hydrogen production got started in 1975. So from this time onwards, industrial scale synthesis of hydrogen is going. But till now, threefold rise in the synthesis is observed. In the current time, we can observe since 1975, threefold rise in the manufacturing of hydrogen got increased. Continues to rise, almost entirely supplied to fossil fuels. Now, every industry is looking forward for the sustainable fuel called hydrogen. That's the reason why there is a great effort for the manufacturing of hydrogen, because it is of high demand for safe utilization. With the 6% of global natural gas and 2% of coal going the hydrogen production. So here anyway, bulk quantity of hydrogen production is carried with our water molecules. In addition, natural gas reforming and as well as coal is also converted into this hydrogen for the various purposes. Now, let us see what is the status of this hydrogen production, especially in the country called India, Republic of India. Here in India, there is a great concern for this hydrogen gas production called a National Hydrogen Mission. On 15th August 2021, and the day, auspicious day called Independence Day, Indian Prime Minister Honorable Narendra Modi suggested that National Hydrogen Mission. So what is the main objective for this one? Decision to transform India into a global hub for the green hydrogen production. Green hydrogen production is nothing but no way hazardous impact will be there during the production and even in the operation state of this hydrogen. So it should be a global hub, and not only for the sufficient quantity of the country's survival, and even for the export for all the other countries. So here that kind of concern will be there in order to launch this National Hydrogen Mission. This is the main objective, aim to become a global hub for the production of hydrogen, not for the sufficient production for the country, but also for the exporting to all the remaining surrounding countries as well. As a result, companies in the India have started making the switch. most of the companies are focusing on the production of green hydrogen, so that there is a momentous transition in the synthesis, manufacturing, and the production of this hydrogen under the mission called the National Hydrogen Mission. What was the talk given? We have to make India a global hub for the green hydrogen production and export. And the Amrit Kal, this will not only help India to make a new progress in the field of energy self-reliant, but will also become a new inspiration for a clean energy transition all across the globe, all across the world, right? So here, this is not only for the country's growth, but also for the collaborative growth of entire universe, entire world. So that kind of futuristic vision will be there. And here they are implementing the production of hydrogen and switching toward this hydrogen as a fuel under the mission called a National Hydrogen Mission, to make the India as a global hub for the production and export, not only production for the survival of the country, but also to export for other countries as well. So that extent, so here that means excessive quantity production is the aim for this National Hydrogen Mission. India spends over 12 million annually, 12 million rupees annually for the energy requirements. Green hydrogen production to help the replace the energy imports. Energy import should be minimized. That is the main objective for this National Hydrogen Mission. See, not only from this hydrogen gas reforming and the coal gasification, high temperature electrolysis of water, this is the most important thing. Photobiological process also implemented in order to synthesize this hydrogen. And here electrolysis and the grid, that extent of energy production is required in natural gas reforming, bio-derived liquids, all these employed in order to synthesize this hydrogen under purely benign manner without causing any impact on the environment. So that hydrogen will be the green path in order to give the grid-based electricity in future. So that's the main intention in the motto of this National Hydrogen Mission. And National Hydrogen Mission aims to develop India into a global hub and to export the hydrogen to any other countries as well under the scheme of Make in India, as well as Atmanirbhar Bharat. So if energy security is there, this energy security is accompanied by national security. Country will be secured in all dimensions. Economic security is possible because import hurdle will be overcome by this process. That will be economy restore is possible, economic flourishment is possible, that will be secured in general. And if we switching towards hydrogen, that more environmental benign, so that environmental security is also achieved. So that if we gain the energy security by means of hydrogen, that will be associated with national, economic, environmental security as well. So these many kind of advantages we can avail by implementing this hydrogen as a fuel. So it is possible to get so many kind of emoluments over here. So here it is described how the hydrogen fuel cell is going to work. Hydrogen is inserted at the region of one of the electrode and oxygen is pumped over here. Hydrogen is working like an anode. Oxygen is working like a cathodic region in this fuel cell. Fuel cell is nothing but this is a source of energy which is considered as an electrochemical cell, where chemical energy get converted into electrical energy as long as fuel supplied, the energy production is possible. Hydrogen and oxygen get supplied and membrane is separating over here, so that here hydrogen will lose the electrons and oxidation get carried over anodic region, and oxygen accept the electrons and cathodic region reduction process get carried. Ultimately they get combined to give the water as the final product along with a lot of energy generation. This is the entire chemistry involved in this fuel cell of hydrogen and oxygen. Here hydrogen anode, oxygen cathode, both will react together and the water as the final product without any harmful emissions over here. Hydrogen enter into anode and atoms get stripped and electrons will be released at anodic region. Positively charged protons will pass into cathodic region. along the electrons, and the oxygen will accept the electrons and combines with this one, and the water as the ultimate final product generated in this hydrogen oxygen fuel cell. Now, work is on board. So how the progress is observed in the production of hydrogen gas? Let us see. Two hydrogen refueling stations got established in India. One is Indian Oil R&D Center, Faridabad, National Institute of Solar Energy, Gurugram. These two are the centers where two hydrogen refueling stations got installed. This will be a green source of energy. Now, in other industries like Indian Oil Corporation, Reliance Industries, GAIL, NTPC, National Thermal Power Corporation, Larsen and Turbo. These are the big industries where there is a focus and production for this hydrogen is on board. So they are implementing various processes, and research is going on in order to synthesize this hydrogen in the bulk scale. So these many companies are working to improve the quantity of production for this hydrogen to make hydrogen as a fuel of the future. And this is the chemistry involved in this hydrogen oxygen fuel cell. Hydrogen is bubbled over anodic compartment, and where hydrogen working like a anode and release electrons along with H plus. H plus diffused into the cathodic chamber where oxygen gas is bubbled over here. So these oxygen molecules will accept electrons along with H plus, so that water got generated and that will be taken out from this outlet. So here, entire process is carried under purely benign conditions. No hazardous effect will be there, and we are most familiar that hydrogen oxygen fuel cell can be employed in the rocket fuel. Liquid hydrogen, liquid oxygen fuel cell can be employed in here because all the gaseous components are lighter in weight, and this is easy to carry into the space aerospace region. That's the reason why it is the efficient rocket fuel. And along here, the chemical reactions also manifested. So hydrogen, upon reacting with the oxygen, there is a formation of water molecules are possible. Oxygen, where we can see hydrogen in the anodic compartment will release H plus into electrons. So here oxidation reaction get carried in the anodic compartment, and whatever electrons and H plus released get transformed into a cathodic compartment where oxygen will accept electrons, so that reduction got carried, and finally water molecule will be generated. This is a reaction called reduction. So that hydrogen plus half molecule of oxygen gives rise to a water molecule as the final product. This is the chemistry involved in this hydrogen oxygen fuel cell. And here you can clearly observe that it can be implemented. Hydrogen gas also implemented as a fuel of transportation of trains as well. So here, this is the application we can observe. Here, chemical reactions are clearly manifested over here. Hydrogen will release H plus and electrons in the anodic compartment. Released H plus electrons accepted by oxygen molecule, and water molecules got generated over here. Finally, hydrogen, oxygen get combined to give water along with a lot of energy. So that is manifested in the three-dimensional representation as well. So here, finally, water and along with a lot of energy will be generated. That energy can be transformed into various forms. Now let us see how many kind of applications we can find, we can observe for this hydrogen as a fuel. So first application, hydrogen production is a major concern for most of the countries. And are focusing in a momentous manner in order to synthesize hydrogen in the bulk scale, being it is 100% clean energy source and distributed all across the globe, water available everywhere, so that here switching towards emission of carbon dioxide can be minimized, and hydrogen production will be maximized in this manner, and that will be used as a fuel for automobiles. So here hydrogen, now we can observe natural gas fueling stations, petrol fueling stations, diesel fueling stations, electricity means electrical vehicle fueling stations are available. Along with that, hydrogen fueling stations are also coming to launch. So that is also possible because it is going to become a automobile efficient fuel. And even in the warehouse logistics, in order to transport the larger bulk quantity industrial material from one region to another region, here in this transport also, here hydrogen fuel is very essential. For this purpose also, hydrogen fuel can be utilized for this logistic transportation. Now, global distribution, here so many companies are moving forward, like Nikola, Hyundai, Toyota, Canworth, Honda, and UPS. Such a kind of companies are moving forward in order to boost the fuel cells, in order to boost the fuel cells which are composed by hydrogen oxygen. And these hydrogen fueled trucks and semi trucks, vans, all these are going to be equipped. And what zero emission or carbon dioxide emission free vehicles are going to be launched, so that there is a global distribution. So most of the countries are focusing in this direction. Now, switching to zero emission by this hydrogen may convert it into a water molecule, so that your hydrogen powered in buses. So buses are major transportation in the terrestrial region. So in this case, hydrogen powered buses are going to be launched. So here, Synthesized labs in India, Chicago, Vancouver, London, and Beijing are experimenting hydrogen-powered buses. These fuel cells are going to be implemented in order to run these vehicles. So that here the research is under progress. So that if the entire things go well, so here hydrogen fueled bus will be the common means of transportation for us. And even in the rail transportation, hydrogen fuel cell trains have now appeared in Germany. Germany already launched hydrogen oxygen-based fuel cells. So here, most of other countries also in the streamline with this, India, Great Britain, France, Italy, Japan, South Korea, United States of America. All these countries are focusing on these hydrogen oxygen fuel cells in order to increase the energy efficiency and reduce the carbon dioxide emissions and all other problems. So here switching towards this hydrogen fuel cells in order to apply as the fuel in the train transportation. Personal vehicles. So here in the private transportation system, especially two-wheelers, four-wheelers, any other kind of electrical vehicles are any means of transportation available. So in that case, also hydrogen fuel cells containing equipments are going to be launched by the companies like Toyota, Mirai, Honda, Clarity, Hyundai, Nexo, and BMW Hydrogen Next. These are the systems, these are the companies which are going to install hydrogen oxygen fuel cells in these automobiles, so that here, even in the public transportation, as well as private transportation, these hydrogen oxygen fuel cells are going to play a vital role. And even in the aerospace applications, so here, several experimental projects like Pathfinder and Helios prototypes are available, and they are testing whether hydrogen can work as a fuel in airplanes or not, and the research is underway. So if it work out here, this hydrogen efficiently used in airplanes as a fuel as well. Unmanned aerial vehicles. So here these are mostly applied in the military and even in the industrial purpose for the transportation of their logistic means. They are employed. In this case also here hydrogen oxygen fuel cells are implemented. Hydrogen being it is a lighter weight element, it is more convenient to utilize and environment friendly in nature. That's the reason why the research is in progress to implement this hydrogen oxygen fuel cells in unmanned aerial vehicles as well, and in other submarines. Even in the marine regions, the vehicle like ships and submarine transportation, energy efficient hydrogen oxygen fuel cells are testing. Air independent power insert for the Indian submarines, not only utilizing this hydrogen oxygen fuel cells can be employed in order to switch for the efficient fuel discharge for this marine transportation as well. Hydrogen fuel cells produce electricity. So here grid-based electricity production is also possible. First of all, we have to take either wind-based or solar-based electricity for the electrolysis of water molecules. After departing hydrogen and oxygen, they get stored in these vessels, and further they can be used as electricity producing devices, and this energy can be supplied electricity to the grid as well. So here hydrogen fuel cells, hydrogen fuel also used for the electricity generation in future. So these many applications we can categorize in general. Power heat generation is possible. Power generation, nothing but electricity production. That means a bulk grid. That means grid-based electricity generation is possible with this hydrogen fuel. And power buffering systems also generated, equipped by these hydrogen oxygen fuel cells. Hydrogen addition to natural gas. So natural gas, wherever we are applying for steam generation, for the transportation purpose, it is used as a fuel. We can blend. So instead of pure natural gas, we can blend with the hydrogen as well. Otherwise, we can switch into hydrogen also. Heat and power for the buildings. In order to heat and in order to provide the power to the buildings, we can use hydrogen as a fuel. And even for the industrial purpose, we can apply in the bulk scale. Industrial feedstock, in the steel production, we require the electricity and a high amount of energy. Ammonia, especially, it is the fertilizer, very essential for the crop plants to grow, because nitrogen is the NPK, nitrogen, phosphorus, potassium, major elements for the crop growth. That's the reason why in the ammonia synthesis also we can apply hydrogen as a fuel. And synthesis of the gases, we can apply this hydrogen. Hydrogen used as a catalyst as well as the starting material in order to synthesize the gases. Hydrocracking. Hydrocracking in the sense, long chain hydrocarbons get fragmented in the smaller pieces by using this hydrogen in order to increase the efficiency of the fuel. In that case also industrial purpose cracking, nothing but breaking of hydrocarbons into the smaller pieces. In that case also hydrogen can be employed. Hydrogenation. So wherever you need addition of hydrogen, hydrogenation is nothing but addition of hydrogen. That is the process called reduction. In that case also here hydrogen can be employed. Fuel cell forklifts. So here fuel cells, these are used as a fuels. Hydrogen oxygen fuel cells can be employed in the automobiles. Hydrogen powered vehicles are available right now. Hydrogen powered trains, just now we discussed regarding this. Hydrogen powered aircrafts also possible for improving the energy efficiency. Hydrogen powered shipping. So all means of transportation, all means in the sense air transport, water transport, road transport, train transport. Four means of quadruple means of transportation can be fueled by this hydrogen, being it is an efficient fuel. Hence, we can consider hydrogen is a fuel of the future. So here it is again mentioned, ammonia manufacturing requires hydrogen as the main ingredient. Heating of the buildings, it is required hydrogen. Road, rail transportation, hydrogen can be used as a fuel. Carbon neutral fuels. So here, whenever we are switching to hydrogen, it will become carbon neutral. Carbon emissions may not be present over here. That's the reason why it will become carbon neutral fuel. And renewable natural gas. Natural gas can be blended with this hydrogen so that its efficiency will be greatly enhanced. These are other applications about hydrogen. Chemical manufacturing, so many chemicals are composed by hydrogen, so that in that case hydrogen is very essential, not only for the generation of energy but also in order to store the energy. This hydrogen can be applied as stationary fuel cells. Fuel cells are the source of energy. Instant energy will be produced as long as fuel supply is there. Energy production is also valuable over here. So hydrogen oxygen fuel cell is more efficient in this regard. Petroleum refining. Refining in the sense purification of petroleum is possible by applying this hydrogen. So that quality of the petrol will be raised. Its octane number will be raised by this purification. In that context, we require this hydrogen. It will reduce them and purify them. All kind of contaminations will be discarded so that efficiency will be raised. And fuel for the vehicles. Just now we discussed about this. So we have a quotation over here. Smaller in size, lighter in weight, simpler in the transport, but brighter in the application, smarter in the efficiency, ultimately substantial future leading fuel, that is hydrogen. We are switching from carbon dioxide to hydrogen, right? So I'm repeating once again, smaller in size, lighter in weight, simpler in transport, but brighter in the applications, smarter in the efficiency, ultimately substantial future leading fuel, that is hydrogen. Thank you very much for your consistent listening. Thank you one and all. I hope this session will be very useful for us, and hydrogen will definitely become the fuel of the future, because all kind of applications are substantial, which are very essential, and it is very essential to move on to this hydrogen as a fuel. Thank you very much. Thanks a lot.